In the years following the Second World War, the world was changing faster than anyone could quite comprehend. Nations were rebuilding, industries were booming, and new technologies were emerging that promised to reshape not only the way we worked, but the very fabric of society itself. Factories, once filled with rows of men and women at assembly lines, became the beating heart of post-war progress. Steel, rubber and oil powered the American dream, while the quiet hum of machines replaced the sound of the human hammer. Yet, in those early years of recovery and optimism, few could have imagined that humanity was already laying the groundwork for a revolution, one not of ideology or politics, but of automation. In laboratories and workshops far from the noise of the production floor, engineers and scientists began to ask a new kind of question. Could a machine not only move, but also decide? Could it sense, respond, even adapt to the world around it? This question, innocent and curious at first, would come to define the coming century. The 1950s are often remembered for their cars with chrome bumpers, their televisions glowing in darkened living rooms, their tidy suburban streets. But quietly, another story was unfolding. A story of circuits and servos, of switches and signals, of humanity's first attempts to create mechanical life. In the early years of that decade, a British neuroscientist named William Gray Walter was tinkering with something that looked, at first glance, like a child's toy. He called them tortoises, small mechanical creatures built with simple electronics and wheels. They could follow light, avoid obstacles, and seek out their own power source when their batteries ran low. They weren't just machines that moved, they behaved. In their tiny movements, in their hesitation and adjustment, people saw the faintest glimmer of intention. Across the Atlantic, in the bustling workshops of American industry, another dream was taking shape. Inventor George Devil filed a patent for a device that would become the world's first programmable robotic arm. His idea was simple in theory, but revolutionary in practice. A machine that could repeat a series of precise motions again and again, without fatigue, without error, without pause. It was called Unimate, and though few paid attention at the time, it would soon become the first true industrial robot. By the middle of the 1950s, the notion of automation was beginning to take hold. Scientists spoke of a future in which factories ran themselves, where machines replaced men in the most dangerous or monotonous jobs. At first, it was a dream of liberation, of technology freeing the worker from drudgery. But it was also the birth of a quiet anxiety. What happens to human purpose when the machine can do our work better than we can? While Devil was perfecting his robotic arm, another mind was probing an even deeper question. In 1950, British mathematician Alan Turing asked the world, "Can machines think?" His paper, Computing Machinery and Intelligence, proposed a simple test. If a machine could converse with a person in such a way that the human could not tell it apart from another person, then that machine might, in some sense, be said to think. The idea was radical. Machines, after all, were meant to calculate, not converse. But Turing's challenge cracked open a door that has never since been closed. Just a few years later, in the summer of 1956, a small group of researchers gathered at Dartmouth College in New Hampshire. They came from mathematics, engineering and psychology, and they shared a belief that human intelligence, reasoning, learning, perception, could, in theory, be replicated in a machine. They called it artificial intelligence. The phrase itself sounded like science fiction, yet it marked the beginning of an entirely new discipline, one that would one day merge seamlessly with robotics. In these early years, the concept of a robot was both industrial and imaginative. Hollywood gave us metal men who walked and talked. Engineers gave us machines that welded and lifted. Between the fantasy and the factory floor, the seeds of the modern age were quietly taking root. In 1961, George DeVole's Unimate was installed at a General Motors plant in New Jersey. There it performed one of the most dangerous tasks on the assembly line, moving and stacking heavy die castings, then welding them in place. It worked tirelessly, silently, without complaint. The workers gave it a wary glance. Some saw it as progress, others as the beginning of the end. But the roots of that moment, that simple robotic arm performing its job, reached back to the 1950s, when these ideas first began to leave the chalkboard and enter the world. The Unimate was not a mind. It had no awareness of what it was doing. But it represented a threshold crossed, the first time a machine took on a truly human role in the act of production. Meanwhile, in the halls of universities, new advances in computing were giving birth to even bolder dreams. The invention of the transistor in 1947 and the rise of early mainframes allowed machines to calculate faster than ever before. By the late 1950s, researchers were experimenting with simple learning systems. Early neural networks that could recognize patterns, adjust to feedback, and improve over time. They were primitive by modern standards, but they hinted at something extraordinary. Machines that didn't just follow instructions, but adapted. In the 1950s, such ideas bordered on philosophy. What was a mind? Could thought itself be reduced to a series of rules, a dance of electrons and logic gates? For some, these questions were thrilling, for others, deeply unsettling. In factories and laboratories alike, the world began to change. The concept of the automatic became synonymous with progress. Washing machines, typewriters, cameras, all boasted new automated features. And yet, the idea of a fully autonomous machine, one that could perform complex human tasks, still felt far away. Few realized that the foundation was already there, waiting for computing power to catch up. The 1950s were, in many ways, an age of faith in technology. The same spirit that sent rockets skyward and satellites into orbit also inspired the vision of thinking machines. Robotics drew from that same optimism. Engineers imagined robots that could help on farms, assemble cars, even explore the moon. The era's popular magazines depicted smiling families served by mechanical helpers, a household where every task was handled by chrome and circuitry. But beneath the gleaming promises, questions persisted. What becomes of craftsmanship, of labor, of meaning, when the machine replaces the maker? Would automation free us or quietly render us obsolete? These questions began to echo through unions, universities, and coffee shops alike. Some dismissed them as paranoia, others saw the writing on the wall. By the end of the decade, robots were no longer curiosities. They were tools. Industry had discovered their potential. General Motors and other companies invested heavily in automation. Entire production lines were redesigned for machines. The rhythm of labor, the pulse of the human hand, was being rewritten by circuits and steel. At the same time, in academic corners, artificial intelligence pressed forward. Researchers built programs that could play chess, solve equations, and prove simple theorems. In 1958, psychologist Frank Rosenblatt introduced the perceptron, an early neural network capable of recognizing basic shapes and patterns. It was rudimentary but revolutionary, the first glimmer of machine learning. Though limited by the computing power of the time, the ideas were profound. The world's first AI programs and robots were like infants, capable of simple tasks, unaware of their purpose, but brimming with potential. And just as the first spark of life in the primordial sea led to everything that followed, these early inventions would evolve into something extraordinary. Today, when we see robots assembling cars, assisting surgeons, or navigating the surface of Mars, we are witnessing the culmination of a dream born 70 years ago. The 1950s may have seemed a time of simplicity, but beneath its surface lay the first tremors of a digital dawn. Artificial intelligence, in particular, has carried the torch of that revolution. From Turing's test to the neural networks that now power our phones and computers, the path leads directly from those first questions asked in post-war laboratories. Can a machine think? Can it learn? Can it understand us or even become something like us? The answers, after decades of progress, are more complex than ever. Machines now write, draw, compose, converse. They interpret data and make predictions with uncanny precision. And while we marvel at their capabilities, the same unease that haunted the workers of the 1950s lingers still. What happens to the human spirit in an automated world? What remains uniquely ours? When we look back at those early decades, it's tempting to see the 1950s as a quaint prelude to the digital age, a world of black and white televisions and mechanical typewriters. Yet, in truth, it was an age of beginnings. The men and women who built the first robots and dreamed of artificial minds were pioneers of a frontier we are still exploring. Their work was slow, often dismissed, occasionally ridiculed, but they believed in a vision, not of domination or destruction, but of partnership. Machines as extensions of human creativity, amplifying our abilities, freeing us from the dull and the dangerous, allowing us to imagine greater things. And perhaps that is the enduring story of the robot revolution. Not a tale of conquest, but of collaboration, a long, unfolding dialogue between maker and machine. Each generation builds upon the last, giving the next its tools and its questions. Today, artificial intelligence writes code, diagnoses illness and pilots drones. Yet all of it traces back to those mid-century experiments when a handful of dreamers began to teach metal how to move and circuits how to think. The robot revolution did not begin with a bang, nor with a declaration. It began with a flicker, a light sensor on a tortoise, a mechanical arm in a factory, a mathematician's quiet question about the nature of thought. From those small beginnings, an empire of automation rose. And as we move deeper into an age where machines not only serve but anticipate us, where algorithms learn faster than we can teach, the story that began in the 1950s continues to unfold. Its ending has not yet been written. The hum of progress still fills the air, quieter now, digital instead of mechanical, invisible rather than tangible. But if you listen closely, it's the same rhythm that once echoed across the factory floors of another era, the steady heartbeat of invention, the sound of humanity reaching beyond itself. The robot revolution that started in the 1950s was never just about machines, it was about us. Our ingenuity, our restlessness, our eternal desire to build something that reflects the best, and sometimes the most uncertain, parts of who we are. And as night falls on one century and dawn rises on another, we may realize that the question Turing asked so long ago, "Can machines think?" was really a mirror turned back upon ourselves. The better question perhaps is this: can we continue to think deeply, humanly, in a world increasingly shared with our own creations? Because in the end, every revolution is a reflection, and the robot revolution, that quiet, persistent, ever-advancing tide, is and always has been a reflection of us.